of HA and its policy so we can understand HA relevant problem. So can you see my screen?
Yeah, Dinesh, it's visible. Yes.
All right. So we sphere HA clusters. How many ESXi we need minimum in the HA and DRS enabled cluster? People waiting in a lobby, please admit them.
Hello?
Okay, so suppose we have 3 hosts, shared storage that is required.
कॉल करना चाहिए था ना तुमको ये सब
And
ऐसे कौन सब है वहां पे
we have our ESXi host.
अच्छा वो कहाँ रहती है होस्ट हेलो
So it is always recommended that make a homogeneous cluster. So we use one term, homogeneous cluster. What does it mean? Make sure every ESXi host using hardware from the single vendor, identical hardware, and they are using they having a equal amount of resources. Technical, it is possible we can make unequal like 100 GB RAM, 1 terabyte RAM, 500 GB RAM. But when you see the HA admission control policy, so you can see if you do not make homogeneous cluster, your HA going to waste a lot of resources. DRS cannot enable trigger the vMotion from any host to any host. So we need to make homogeneous cluster, make sure all ESXi using identical hardware and equal amount of resources. So just for an example, we have 10 GB to make our easy calculation. So when you add this ESXi host in a HA cluster, so every host submitted its resources to the cluster. So cluster say I have 30 GB RAM, but individual host say I have 10 GB RAM. So then we're going to place virtual machine, VM, and as we know, this virtual machine must be on the shared storage.
शुगर हाई होने के कारण एडमिट फिर उसके बाद हमने बोला कि कम से कम फोन तो करना चाहिए था.
So these virtual machine relevant folder get created in your shared storage, and all hosts have their visibility for their all the registered powered on powered off virtual machines related all file in the storage. And we want protection. We want to provide protection to all the virtual machines. So it means what we need to use HA cluster, and within this HA cluster, we are going to use HA admission control policy. So once we use HA admission control policy, and temporary, you can consider if what happen if I disable this HA admission control policies. So if you disable it, it means it not going to stop you even you start utilizing all 30 GB RAM.
हाँ फोन किया तो बीच में।
But the problem is whenever hardware failure occur, one of the ESXi failed,
हो गया
it cannot recover the virtual
अभी
machine
हॉस्टल में है
because we do not have free resources in the another ESXi host. So might be some virtual machine it can power on, but not all.
ये बोलना तो चाहिए कम से
So
कम
if you want
बराबर
guarantee for existing all virtual machine, whenever hardware failure occurs, it must be survived, automatically come up. So first thing, enable always admission control policies. Once you enable, the first policy we have, where you can see this cluster can tolerate one host failure. What does it mean? Out of 3, if one host goes down, you have guarantee all virtual machine must be come up in the another ESXi host. If you have bigger cluster, 10 ESXi, 30 ESXi, or maximum 64 ESXi in 7.0. So you can configure this value 1 to 2, 2 to 3. Out of 30 ESXi, 3 hosts filled together, still your all virtual machine automatically fail over to the other remaining ESXi hosts. So because of our cluster is small, I'm considering one host failure out of 3. Whenever we lost, your existing virtual machine must be automatically come up in the another survived ESXi host. So at a moment we enable the policy, it's going to do its own calculation. What is that? It's going to make slots, logical memory slot, logical CPU slots. Whatever I'm going to calculate for the memory, same thing you can consider for the CPU. CPU also might be, we have 30 gigahertz in the cluster. So it's going to check, is there any virtual machine where we configured highest amount of reservation RAM, CPU? In some virtual machine, let's say I configured the reservation 512 MB, 700 MB. There is a one virtual machine where I configured reservation 1 GB. So it's going to take this highest reservation amount and divide this from the total available memory in the cluster. So total memory we have 30 GB divided by a highest reservation which is found in one of the virtual machine configured 1 GB. So 30 divided by 1. If it found 2 GB reservation, then 30 divided by 2. So in our case, 30 divided by 1. So 30 divided by 1. How much value we get? Again 30. 30 divided by 2 if, then 15. So 30 memory, logical memory slots it create. And each logical slots is 1 GB. 1 GB. 1 GB. 1 GB. If suppose highest reservation 2 GB, then 30 divided by 2, total slot 15s. Each slot size then it would be 2 GB, 2 GB, 2 GB, 2 GB. But in our this calculation, we take 1 GB. We consider 1 GB is the highest reservation. And each slot size 1 GB, 1 GB. So total slots in the cluster we have 30. So if you ask from the cluster how many logical memory slot do you have? 30. But individual ESXi host say how many it has? It has individual host. How many memory slot we have in a single ESXi host? 2, 3, 5, 6, 7. How many? Are you getting what I'm trying to explain? If cluster level we have 30 slots, individual host level, how many slots we have?
It should be 10.
Yes. Because of the each slot size is 1 GB. So cluster level we have if 30 slots, number of slots 30. So individual host level we have 10. Yes. So each host, because of having 10 GB, 10 GB, 10 GB, so total slots 10. And because of we configure this cluster can tolerate one host failure. So in future, out of 3, whenever one single hardware failed, that time how many slots we going to lost from the cluster?
10.
10. So this calculation it does in advance. 30 minus 10, 20. So it means what? In this HA admission control enabled cluster, you are allowed to use 20 slots only. 10 slot it keep all the time free. In this HA cluster to gives you failover guarantee for existing all virtual machine. So whenever you can see from the cluster summary, how many total slots we have, how many slots consumed, how many slots left free. If it's showing free slots 0, it means you consumed all 20 slots. Now you are not allowed to power on any single more virtual machine. Max to max, you can power on 20 virtual machine in this entire cluster, not more than 20, but might be less than 20 also possible. I have a one virtual machine configured with, let's say, 5 GB RAM, and internally it using 3 GB RAM. So 3 logical slot might be gone to one single virtual machine. In that case, you could have less than 20 virtual machine also in this entire cluster. But once you consume all 20 slots, it will not allowing to you to power on any single more virtual machine. So if we don't know this concept, whenever we face problem trying to power on VM, it trigger the message because of insufficient, you cannot power on the VM. And when you look at the cluster level, you can see a lot of resources still it's showing free. So this is the reason, because 10 slot it must need to keep free. Now you can see with this calculation you have 100% guarantee, you have 20 slots. So it means let's say I have 7 slots, 7 virtual machine here, 7 virtual machine here, and 6 virtual machine here. So now you can see if any host failed, let's say first host goes down, so it can power on 4 virtual machine here, 3 virtual machine here. If the middle one host goes down, so you can power on 3 virtual machine here, 3 virtual machine here. So out of 3, any host, whenever you lost, you just lost 10 slots, 20 slots still available. So you can say half of the virtual machine here, half of the virtual machine on the other host, you can still recover. But with minimum downtime, we never say we do not have downtime. In that HA cluster, suddenly hardware failure occurs, so we lost the memory state of the virtual machine, which were completely exist in the ESXi host physical RAM. But with this small minimum amount of downtime, you have advantage. So this kind of clustering concept works with all supported operating system, whether it is Linux, Windows, or other supported operating system. Even you have Windows 10, Windows 7, Windows 8 client operating system still. This kind of protection we can provide to all the virtual machines. But this policy also gives you another problem. What is that? Let's say in one of the virtual machine, we configured very high reservation. Let's just for an example, we have in one of the virtual machine 10 GB reservation. Only single VM I have in this entire cluster with 10 GB reservation. So if it use this same default algorithm, so 30 divided by 10, how much? 1, 2, 3. But this time, each slot size is 10 GB, 10 GB, 10 GB. So in this entire cluster, you have only 3 memory slots. On the top of that, in future, whenever you lost one host, you're going to lost one slot. So 3 minus 1, 2. So in this entire cluster, you can power on only 2 virtual machines. So it means what? I have one virtual machine where I configured 10 GB RAM. For this virtual machine, 10 GB reservation, it's okay. One 10 GB slot gone to this virtual machine. But what about this virtual machine? Where total configuration is configured 1 GB. Total RAM is configured 1 GB, but for this virtual machine also we consider logical 10 GB slot gone to this VM. So you have one slot 10 GB for this virtual machine, really need it. But another VM also take one logical slots that is 10 GB. So 20 GB gone. And third virtual machine, you are not allowed to power on. What does it mean? So lot of resource wastage. So if you have this kind of difference, VMs to VM, big difference in terms of reservation, don't use HA admission control first policy, use the second policy. Some sound coming from your end, please guys mute yourself. So within this admission control policy, you can use the second policy. Second policy say keep resources free in percentage. If you use second policy, when VMware recommend to use second policy and first policy, if you have identical reservation in all virtual machine, you can use the first policy. If there is a big difference between the virtual machine to virtual machine reservation, memory, CPU, you can use the second policy, which say keep resources free in percentage. The second policy, when you use it, not going to check you configured how much reservation, not going to make any slots. So we can configure, let's say 20% CPU, 20% RAM. It must need to keep all the time free in the cluster. 20% of 30 GB RAM, it must be keep free. Or you can configure if you want 33% of RAM. If you consider one entire host goes down, still it has 33% RAM available as a spare RAM, free RAM, provide failover for all the virtual machines. So we can change this 20%, 10%, 25%, 30%, or even 50%. Half of the ESXi field in the cluster, still you can survive, but might be possible failure never occur for next 5 years. So a lot of resources we are not able to use. So appropriately, we need to configure percentage. Within this percentage, you should know it can provide one host failure, two host failure, or more host failure. That depends number of ESXi, how many we have in the cluster. And we have also third policy, that is dedicated host for failover. If you want, you can create. There is a 1 or 2 dedicated ESXi host where this host is a dedicated only for failover, So it means at a moment we select within a cluster one or more host as a dedicated host for failover. It will give you message if you have some power on VM, move them. Because this dedicated host must be all the time free without any VM. It is powered on 24/7 by 365 days, but without any single powered on VM. If you have, when you make this dedicated host for failover, you must need to move the all existing virtual machine, make it empty. And in this policy, it is also possible other host we have, suppose 10 GB, 10 GB, 10 GB, you can have the same 10 GB. In case it will give you one host failure, if you want two host failure, we can place 20 GB RAM. So any single or two host failed, its virtual machine failover only to this dedicated host. And this is all the time running without any virtual machine. Sometimes your internal organizations have this kind of policies. If they have this kind of policies, you must need to follow. And in that case, we can use this. They want a dedicated one or two host for the failover. So whenever failure occurs, they can immediately access their ESXi host that their customer virtual machine must be running or not. So if you have internal policy like this, you cannot then use first and second policy. But if you have freedom, we always prefer first or second policy as per the condition. If you have equal amount of resources, go to the first policy. Big difference between VMs to VMs, reservation, go for the second policies. And how they perform the failover? Because if you see in the HA cluster architectures, when you place ESXi host in the cluster, immediately what happened inside? There is a election process take place among all the ESXi host within a cluster, and the host which win the election become master and other host becomes subordinate. So there is a election process, and this election process, election traffic, we have every ESXi host using the management network. So just to make it clear, let's take I have a dedicated switch with physical network connectivity where I am managing VMK0 management traffic. Then I have uplink VMK1 storage traffic, and then I have virtual machine traffic. So elections, whenever take place among all the ESXi hosts, they use the management network. That's why management network also known as a heartbeat network. So when the elections take place, every host participate for the election, and the host which win the election become master. And other all hosts within the same cluster become subordinate. Subordinate. So what is the job of the master host, subordinate host? Master job is to check whether subordinate host is up and running or it is
अभी
failed.
घर जा
No
रही
more
है तो
available.
तुम्हारी क्या बैट बजेगी?
And it is the master
देखना
host
5
who
बजे?
participate for the
हाँ।
failover process, trigger the failover process. And we have one condition that is called isolated host. Isolation occur in your HA cluster when one of the hosts lost its management network only. Storage network, no problem. And the virtual machines traffic, no problem. Okay, now tell me one questions to you. The VM is going to perform its read write in a flat.vmdk. I have LAN card 1, LAN card 2, LAN card 3. Which LAN card get involved out of 3? Did you get my question? Virtual machines want to perform read write in the flat.bmdk. Which LAN card out of 3 get involved?
अरे यार
क्या कर रहे पूछ रही हो तो बता नहीं रहे कब से
The LAN which is
तुम्हें क्या
connected to
दिख रहा है?
VM for network traffic.
That is what expected from the common audience, this answer, but that's not true. That is what you need to make your understanding, because it is actually give the natural way how you answer this question. VM connected to this switch, so it means VM want to perform IOPS. You simply say LAN card 3.
तुमने कार ले लिया मतलब 3 साल तक कहीं जाने वाले सिंचर में काम
By using which LAN card I can access storage? Where is the flat.bmdk exist? In the storage, and hypervisor accessing that storage from where? LAN card 2 it using to access the storage. Whenever virtual machine needs to perform read write in a flat.bmdk, it is the hypervisor who intercepting their read write and forward those read write to the flat.bmdk in the storage by using the LAN card 2, not LAN card 3. What is the use of LAN card 1?
This will just for the vMotion and all this stuff, management things.
Management, right? As per given scenario, yes, you can use it for the vMotion also, FT also. Generally be clubbed together, FT management and vMotion traffic together in the same. And redundant, 2 LAN card, 1 more LAN card you can plug here. So first LAN card to the host management traffic. Over this network, it communicate also with other host, master host, and as well as vCenter server. Virtual machines all read write on a flat.bmdk hypervisor using second LAN card. Now tell me, what is the then use of LAN card 3?
Basically, LAN card 3 will work for the user traffic.
Users traffic, RDP traffic, right? OT traffic. You are coming into your virtual machine from the internet. So your traffic coming in by using the LAN card 3 or VMs to VMs communication across the ESXi. VMs to VMs communication across the ESXi. The LAN card 3 get fully involved. In the NSX context, we use the term north-south, east-west communication. East-west communication represent your VMs to VMs communication within a data center. VMs to VMs communication known as east-west communication, and north-south communication when VMs to internet, internet to VMs. This is called north-south traffic. So this LAN card, which we have here on the LAN card 3, that is for the virtual machines traffic, virtual machines communications traffic, VMs to VM across ESXi, or VMs to internet, internet to VM, right? So you also need to develop this kind of understanding. If someone, your manager saying, okay, please, we want to get more bandwidth for the virtual machines, or read write means storage, add one more LAN card. So instead of here, you added, suppose here, one more LAN card. So it means for the north, south, east, west traffic, you're providing more bandwidth, but till their IOPS not getting any kind of improvement. If you want their read write should have more bandwidth, so you know better in which switch I need to add my this LAN card. Okay, so we're discussing the isolated host. When the isolation conditions occur, one of the hosts lost only its management network. So what happened? After subordinate master host get elected, so the job of the subordinate host in every second send its heartbeat to the master host by using the management network, and and master also send its heartbeat to all the subordinate hosts over the management network. So the master host comes to know they are alive, they are working. If these conditions occur, it means what? Master not receiving any heartbeat or not able to send heartbeat. So how the master host should understand this condition, that ESXi only partially down, it lost only management network, whether or it is really dead. How the master host comes to know, because as it is not getting any heartbeat from this specific subordinate host. So don't forget, when we add these ESX and HA cluster, there is a one folder also get created, vSphere HA, named folder, .vSphere HA folder. And in which data store it get created automatically? That data store also known as a heartbeat data store. Heartbeat data store. So in this folder, every host creates its own file. Master host has full access, can read any host relevant based file, but subordinate host can read only its read and write only its own file. So whenever you power on, powered off any virtual machine, so every host access its own file in this .vSphere HA folder, named folder, and its own file, update that information in regular every 5-second interval. Within next 5 seconds, might be you powered on new virtual machine, powered off existing virtual machine. So host immediately comes to there and update the virtual machine name and state. VM1 powered on, VM2 shut down, VM3 suspended state. So when this happens, the master host first also get confused whether I have a problem, in my network, or the other host has problem. So it's going to check, it's going to send one ping to the gateway. So don't forget, every host using the VMK0, where you have IP address, subnet mask, and default gateway. And default gateway is the physical router, this interface IP. So it's going to check, can I ping this gateway? Yes, it can ping. So it means in my own end, networking related, I don't have any issue. But let me send heartbeat to this ESX. Let me send ping.
नहीं अब मैं बताता
No
हूँ
response.
तुम्हारी बात पे भेज
So
रहा हूँ।
while the master host testing these all activities, same time this subordinate host also testing, because it is also not able to send heartbeat, receive heartbeat
ये
from
किन्हीं
or to the
expect
master host. So it also going to check. Send ping packet to gateway. No response. Okay, now this host going to check via using the storage network, the virtual machine status. Yesterday we discussed whenever you power on the VM, the virtual machines files get locked by the source host in which you powered on the virtual machine. So it's going to check the storage. Storage is still accessible. Virtual machine still in a locked state. So it means they are healthy, working. So this way it identify that I am in isolation. I'm an isolated host now. So if it identified itself that I'm isolated host, what I need to do? So default isolation response is leave VM powered on. But as a vSphere administrator, the problem is if these conditions occur, you can go to the vCenter server and this host starts showing disconnected. So this host based all virtual machine, you lost visibility from the vCenter server. So to avoid this condition, what you can do, you can change the default isolation response from keep virtual machine powered on to shut down your virtual machine. You can change from the HA cluster property, you can change the isolation response whenever this condition isolated host occur. It should be shut down its virtual machine, because when it shut down its virtual machine, log file get released and now the master host become active. So once master host make all its testing, say, okay, once it get confirmed that I'm not able to send ping to this specific host, okay, go to the vSphere.ha and check for next 10 seconds whether this host comes to its file to read or write something. So 10 seconds is the waiting period. So waiting, and every host updates its file in a 5 seconds. Because of its storage network still available, virtual machine network still okay. So it comes to this vSphere.ha folder and put the timestamp, update its file. So the master host know that thing. Okay, so host, it means it is powered on, running, but it lost its management network. Okay, so that host, the isolated host. So it waiting, let it trigger the isolation response. So when this host trigger the isolation response as we configure shut down your virtual machine, so all three virtual machine get shut down by the source host. So it's these virtual machine relevant log file get released. Now the master host pick up those file evenly to virtual machine registered within itself, power on. Third virtual machine talk to another subordinate host. This subordinate host access third virtual machine within itself, powered on. VMs were powered on, remain powered on. VMs were shut down state in, so registered successfully, but keep it shut down state. State of the virtual machine must need to maintain. If all are power on, then power on, power on. All three virtual machines. So now we can see when we prepare our HA cluster, from where we can configure HA cluster, DRS cluster, vMotion feature, which vSphere components provide these all advanced vSphere functions. HA, DRS, FT, vMotion. What components of vSphere provide these all features? Yes? vCenter. vCenter server only gives you centralized management and vSphere advanced features. HA cluster, DRS cluster also, without vCenter you cannot create. And vCenter server we have as a virtual machine running somewhere in the ESXi host. So let's say I have a VM running in as a vCenter server in a third host, and third host suddenly crashed. And we can configure HADRS vMotion only from the vCenter server. What do you think? If I lost ESXi host where we have vCenter server virtual machine also running, should HA work or not? What do you think?
It should, right?
Again,
It should work.
loudly. It should work or should not work.
I think it should work.
Yes, it should work, and it worked. It works very well. Even you lost ESXi 03 where you have vCenter VMs running. Because of once you add ESXi in the HA cluster, we place one HA agent additional FDM called domain management. FDM. Along with host D VPXA, we have FDM. So once FDM takes successfully placed in all the ESXi host, now it has no more dependency on vCenter server. All the HA functionality taken care by the FDM HA agent. So even you lost ESXi 03, you lost vCenter server VM, still HA trigger the action. Restart this vCenter virtual machine in another ESXi host. Once it come up, you again can make changes regarding the HA cluster, DRS cluster if you want. So this is your architecture of HA, how it works. So we can now see what is given. We can understand relevant problems if you know the architecture of HA cluster. Any questions so far?
वो तो मैं कॉल की ना तो पूछ रहा है कौन तो मैं बोली शिवानी इतनी खुश हुए मुझे कैसे कैसे कॉल
Can you see my PPT? Module 6 troubleshooting vSphere clusters.
बस ऐसे ही याद है कि मैं कॉल
Yes.
All right.
ठीक है आज पहले वहाँ के टीचर थे अब वही हो गए
You can see now a review of vSphere HA, that what I have given to you already, the complete HA architectures. So minimum 2 or maximum in 7.0 64 ESXi you can have in a single cluster,
आगे बढ़
and default agent running in all ESXi host D, host D, host D. When you register this ESXi host in a vCenter server, then vCenter server make the VPXA agent available. This is the vCenter server agent, but running in the ESXi host, because VPXA can receive all the instruction from the VPXD. VPXA to host D and host D to the ESXi hypervisor. And when you create HA cluster and add one by one all ESXi in the HA cluster, so what happened? Additional FDM agent get placed. The first job of the FDM agent, let the every host participate for the election. The host which win the election become the master. On what criteria based host can win the election? What is the criteria? You can see one host win the election and it becomes your master. other becomes subordinate. So what is the criteria to win the election and become master? So first criteria we have number of data store. It's not
और ऐसा ठीक है पीछे पता नहीं
all
क्या
the time possible
सप्लाई नहीं जा
that
रही है
every host claiming equal number of data store. Might be some host accessing 3 data store,
हमें
some
फैब में क्या क्या
accessing
लेना है
4
ना एक
data
लिस्ट
store,
बनाओ
and some accessing number of data store 5.
फैब
दो
15
साड़ियाँ लेनी है बाहर के
Who have large more number of the data store available, win the election, become master. But in our this criteria, where every ESXi host accessing 3 data store, the conflict comes. Everyone claiming equal numbers. Drop the parameters. The second parameters, which host has highest MOID, member object identifier. It is just numbers. Let's say we have 30 numbers, 55 number, 79 number. So which host has highest MOID win the election, become the master. So who issued the MOID and when? It is the vCenter server. Very first time when you add ESX in the vCenter server, MOID get issued, assigned, random number. So it's going to check which host having highest MOID win the election, become the master, other all become subordinate. And every subordinate in every second send its heartbeat to the master by using management network, and master also every second send its heartbeat over the management network to the other all subordinate host. And data store where this folder .bsphere folder get created, and that data store known as a heartbeat data store. Every host create its own file, and that file at regular interval 5 seconds keep updating. Master host can read all the files, all hoster specific files, but subordinate host can read and write its only own file. Failing to enable HA. If vSphere HA fails to enable, take the following action. Disable, re-enable, you have this option, When you right click on the ESXi host, you have this option. Reconfigure HA. So when you reconfigure it, going to place again FDM agent.
Sorry, Grish, sorry to cut you. Can you please explain the MOID again? So it's not clear to me. What is this MOID and how it works? Can you please explain it once more?
Yeah. So actually, see, very first time when you add ESXi host in the vCenter server, very first time, that time this vCenter server issue one MOID, member object identifier. And it's not only for the ESX, even when you deploy a new virtual machine, every object in the vCenter server get one MOID. Command line only you can see it. And MOID is just a random number, 40, 33, 65. Every host get this MOID at the moment you add or registered ESXi in the vCenter server. So once you later on first add the ESXi in the vCenter server, you do not have right now any cluster object. But later on, when you create HA cluster object and going to place one by one each host, drag and drop in the HA clusters, that time first criteria being checked by the FDM agent, that is which host claiming highest number of data store. So suppose one host say I have three data store available accessible. It's saying also 3, but it's saying I have 4 data store. I have 2 local data store. So this win the election, become the master. and the cluster entire process never need to use MOID. But if every host claiming equal number data store, I have 3 data store visible, 3 data store, 3 data store. So who going to win the election? No one. So they drop this criteria. Now the FDM going to check second criteria. Okay, send me your MOID. Every host now sending their MOID. My MOID 40, my MOID 33, my MOID 65. So it's okay. Which host having 65 MOID win the election, and it becomes the master host.
What is the criteria to provide? What is the criteria to provide the MOID? Like as you said, like whenever any success added on the HA cluster, then it provide MOID. So what is the criteria to provide the MOID? It
no criteria. It is a random number. Yes, correct. It is a random number.
So let's take an example. Like we have all these ESXi 1, 3, ESXi 2, 3, and ESXi 4 have the 4 data store. And the MOID is for ESXi 3 is less. So firstly, it will check the data store and then.
Yes, correct. That's what I already explained. First, it check always the number of data store. Even I have, let's say MOID 65 belongs to this one, but the number of data store, suppose I have 5 here. The first criteria is number of data store. Based upon that might be win the election, become the master. Even the third host having its MOID highest 65, but it becomes subordinate.
Okay, fine.
Yeah. So MOID is the second choice when there is a conflict occur. So they drop the first criteria, then they're going to work on the based on the second MOID criteria to declare which one become the master host. So when we add ESXi host, as we know, FDM take place, but sometimes FDM stop responding. So what we can do, we can either disable or enable HA or right click on individual ESXi host and we have this option reconfigure HA cluster. And this checks resolve most of the problems regarding to HA cluster. Check the fault domain management agent based logs file in the ESXi host, search for any error in that logs file. And always also we need to look into the release notes. In the release notes, for each VMware solution technology, VMware separately maintain its release notes. So release notes gives you the existing bug fix information. Whatever bug fixed by the VMware, that information we can find in the release note. You can simply make a Google search even release note vSphere 7.0, vSphere release note 6.5. So might be whatever issue we are facing, that comes under the category of known problem, well-known problem. So it means VMware developed the solutions for that, bug fix for that. So we must need to look into the latest release notes. Might be whatever problem we are facing, the solution is available in the release notes. Identifying possible causes. If the ESXi host in the clusters are operating properly, take a top-down approach to troubleshooting. Verify that vSphere HA is configured properly in the vCenter server. So vCenter server only is the way from where we can use the vSphere advanced all features, including vSphere HA cluster also. So HA related configuration, we need to verify the data store for HA heartbeat is accessible from all the ESXi host or not. That also we need to check. And ESXi host level, FDM agent might be not installed properly. When you enable HA cluster, you could have 30, 40, 60 ESXi. So that time election traffic carry on among all the ESXi host, if you have that time network congestion, so the output is might be few hosts left without FDM agent because of that time heavy congestion in the network. Network connectivity is lost between the ESXi and the vCenter server when you enable HA cluster. And the ESXi host is not properly connected to the vCenter server. Incorrect configuration related to vSphere HA cluster. vSphere HA might not be enabled because it is misconfigured, and verify that you meet vSphere HA cluster requirements. First of all, it is even not recommended to provide IP addresses for the ESXi host from the DHCP. But if you plan to have DHCP server, make sure we have DHCP server high available. DHCP has its own high availability. When DHCP goes down, still your ESXi can obtain the IP address from the additional DHCP. All hosts must have at least one heartbeat network. So management network, vSAN network, if vSAN was first enabled on the cluster, we can use both network for the heartbeat network. Best practice to have at least two management network so we can avoid the host isolation conditions from occur. So two redundant network for the management network, also known as a heartbeat network. So one management network not available, we still have another management network. So this way we can avoid the host isolation condition. To verify that any VM can run on any host in the cluster, all hosts should have access to the same virtual machines, networks, and data store. So make sure virtual machines which you want to protect through HA must be available in the shared data store, which is accessible from more than one data store. At least two hosts must be in the cluster. That is mandatory conditions. Minimum two or more hosts. Then only we can configure or use the cluster. Clustering concept means if some services failed, still you can survive. Maximum possible times we can keep our applications up. So from where we can configure it. vSphere HA turn on from the edit setting. And what is this? Proactive HA. Are you aware about this feature? This feature we can use if you integrated one more solutions of the VMware that is called VROps, Virtualized Operation Manager. If you integrated that, then you can use this feature, but without Virtualized Operation Manager, whatever we discussed, that also available. So we just need to turn it on and see how many data store working as a heartbeat data store. Are they accessible, visible from all the ESXi host or not? If FDM agent cannot be installed on the ESXi host, perform the following checks. Check the FDM logs file that you can find under the same directory, fdm.log. Verify sufficient network bandwidth exists between ESXi vCenter server. If network traffic throughput is causing the issue, check for hardware problems. Use BDFS to check the disk space available. FDM, when going to install it, going to take a space. So when you run the script also going to create this kind of problems. It's going to make one of the partitions full. So when you enable HA in that particular host FDM, it's not placed successfully. So that also we need to verify. Make sure all the disks having sufficient space available. And under this FDM directory, you can see some cluster HA cluster related files. Cluster configurations file, FDM configuration file, how many hosts we have in the cluster, how many virtual machine you have in the cluster, that all you can verify from these configurations file. Loss of network connectivity between ESXi and vCenter server might prevent HA from being enabled. So when we enable HA, FDM must be take place in all the ESXi hosts. So we can check the connectivity. As we know, the basic commands to find the network related issue. If ping fails, troubleshoot ESXi host network connectivity. If ESXi host not correctly connected to the vCenter server, check ESXi host connection status in the vCenter server hierarchy. And if the host disconnected, again reconnect it. You have the option. Right click, add ESXi host, or right click, reconnect ESXi. So this could be one of the problems we face in HA cluster when we power on the virtual machine. Insufficient resources satisfy configured failover level for this vSphere. If you look into the cluster level, you still can see a lot of resources I have available. Why it giving insufficient resource message, not allowing you to power on the VM. You can see the slots, number of slots, 0, cannot power on the VM. And slot based upon the default calculation, highest reservation CPU, highest reservation RAM. We need to find a VM, make sure unnecessary we do not have highest reservation RAM or CPU configured. Because of that, number of slots very small, and we consumed all the space slots. So in the vCenter server, you see this message. The problem occurs when you try to power on the VM that is part of the vSphere HA cluster with insufficient failover resources. So if the available slots showing 0, it means now you cannot power on any single more VM. Excessive VM reservation or insufficient resource in the cluster can cause insufficient failover capacity for vSphere HA. Use a bottom-up approach to troubleshoot this problem. So vSphere HA admission control policy is not configured correctly. Might be I want to use keep resources in percentage, but I configured the first one host failure where the default calculations of making slots take place, and we have heavy reservation VMs to VM configured. One or more virtual machine have excessive reservation. Because of that, number of slots get highly reduced. And ESXi host, the cluster has insufficient, you're really facing a crunch for the resources, CPU, memory. What exactly out of 3 you have a problem, we need to investigate. So when you do the labs, you must need to check this thing. First 2. Insufficient physical resources. A cluster with insufficient physical resources might cause this error message. You can use various strategies to resolve the resource problems. Simple, add more physical resources by adding ESXi. New ESXi you adding in the same cluster. And if it is not possible, so in your existing hardware, you can add more hardware, more CPU, more RAM, or build a new cluster. This strategy is reasonable if you are deploying small cluster of homogeneous. If you have some hardware belongs to Intel, some AMD, do not put together in the same cluster. Instead of one, you can create 2 cluster or multiple cluster. One dedicated cluster for Intel hardware another dedicated cluster for AMD hardware. So DRS would not have any issue to move the virtual machine from any host to any host. We will be going to see in the next module vMotions, and then we're going to see that. Some virtual machine in a cluster might have much larger memory or CPU reservation than the other virtual machine. That's why insufficient resource to satisfy configured failover level for the vSphere HA get triggered because you do not have now free slots left in the cluster. Even enough resources we have free, but we cannot use them because of high reservation we configured in some of the virtual machine. So you can see here, from here you can configure this number of host failure to tolerate in the cluster default 1. You can increase that 2, 3, 4, 5. That depends how big your cluster is. Define host failover capacity by you have another option. If you know VMs to VM, I have heavy reservation, but I want to use more slots available in the cluster. So what you can do, you can overwrite the default calculation by giving some value manually from here. You say don't use your default calculation to create slots. I'm giving you the number. Default is highest reservation. Ignore that. What you have to use for CPU, use 32 megahertz. Total, you have 30 gigahertz divided by 32 megahertz. That many CPU slots you have. 30 GB RAM, do not need to divide by 1 GB, 2 GB as per the reservation configured in the VM, but you need to do what? 100 MB. So 30 GB divided by 100 MB. So you have so many slots. Each slot size 100 MB, 100 MB, 100 MB. If you powered on one virtual machine with a 1 GB, so 10 memory slot, roughly 10 or 11 memory slots gone to this VM. So this way we can avoid the wastage of virtual machine, because if you configure 10 GB reservation, it means that VM really need that much memory. It is a database server. You cannot reduce it. But still you want to avoid the wastage, you can provide the manual number. Don't use your default calculation. Use these number what I'm providing from here. So manually these are editable. So each slot size now you have 100 MB. Per virtual machine might be you need 10, 20, 30 slots. So more virtual machine you are able to power on in the HA cluster. So memory reservation related information also we can track from the logs file. Failed to apply memory configuration for the Linux 01 virtual machine, minimum, maximum, that all parameter you can check through the command line, or through GUI also we can check that all the option, right click, edit setting, expand the CPU section, memory section, and we can see. Error admission check failed for the memory resources. So whatever memory you configured, that cannot satisfy by the HA cluster, so you cannot power on the virtual machine. Verify that your HA configurations perform as required. So perform as required. So you can see all the configurations, just edit it, whether it is turn on, turn off, that first we can check and then edit, and we're going to see all the parameters. Host isolation response, what you have configured. And there are several settings you also can configure. like if you have domain controller, database, app, three running in the ESXi host field, HA going to power on the VM. So if it power on first app, DB, then DC. Even these successfully get powered on, but app cannot work. Because you should be in proper order power on the virtual machine. First should be domain controller power on, then database servers, and then at the final application server must be powered on. These kind of also you can configure from the edit setting. You have a priority, high, medium, low. So first it's going to start the virtual machine, but as per you configure the priority, first it should power on domain controller, database servers, then the app. So you can see under once you enable HA, admission control, you have these settings to configure one host failure, two host failure. From drop down list, you can select any, or manually you want to overwrite that. So these three and policy we can configure under HA admission control policy. First, we have slot policy in which it's going to calculate the slot size. Second, we have keep resources free in percentage, calculate spare capacity based on total resources requirement to power on the VMs, and dedicated host only for the failover. So whenever any host failed where our workload is running, it's going to power on, failover the VM on that specific which we configured dedicated host for failover. Only in that host, it's going to restart or recover your virtual machine. So now, whatever we have done already, you can see same thing here. The slot size calculation, if you are using, let it use default calculation. So you can see we have these number of virtual machine 1, 2, 3, 4, 5. Going to check in which virtual machine you configured highest reservation. So let's say for RAM perspective, it picking up this virtual machine because it found highest reservation in terms of RAM 2 GB. For the CPU, these are the 2 VM where it found the highest CPU reservation 2 GB. So now total CPU, how much you have? So suppose individual host wise, if you see total CPU, I have 9 gigahertz divided by 2. 4 point something, but it only take 4. And same thing, 9 GB RAM divided by 2 GB. 4 point something, it take a 4. But if you look in this host, where if you see the CPU 9 divided by 2, 4 point something, it's okay. So we have 4 CPU slots, but RAM 7 divided by 2. 8 point something, it only take 3. Now here see CPU slots we have 4, but memory slots we have 3. And whenever we run or power on any VM, VM needs CPU as well as RAM. It's not like we provide only RAM or only CPU. VM need both. So that's why if you have this unbalanced host, it's going to show instead of 4, 3 slots, minimum numbers, 3. Allow in this host to manage 3 slots, 3 slots. So total slot, this as per this calculation, 3 plus 3 plus 4, 10 slots. And this is not homogeneous cluster because homogeneous cluster, make sure all hosts must be 4 slot, 4 slot, 4 slot, or 3 slot, 3 slot, 3 slot. Because if you do this kind of clusters, and when it see total slots, I have 10 minus, it's going to minus the ESXi slots with highest value. Highest value we have 4. So 10 minus 4 is equal to 6 slots. Only it allows to you to use 6 slots from the cluster. But to keep 5 virtual machines all the time on, in this cluster, I need 5 slots only. So it means in future, even I lost the biggest resource-based ESXi host, I just lost 4 slots. For these all 5 VM, I need 5 slots. Still, I have 3 plus 3, 6 slots. So whatever virtual machine running here, no problem. They can successfully power on the another 2 ESXi host, as they have 6 slots available and the required to keep all the 5 VM up and protected, 5 slots required. So that's why we should avoid this kind of cluster. Otherwise, you can see 10 minus 4, 6 slots only we can use. So whenever you lost the host where we have 4 slots, no problem. Still, we end up with 6 slots and the required slots 5. No problem. We can have all the VMs available, even one hardware we lost. So after determining the maximum number of slots that each host can support, the current failover capacity can be computed. In this example, current failover capacity is 1 host failure the cluster can tolerate, and then that one host could be any out of 3. Any one hardware failure occur, the existing VM still can survive, automatically come up in the another ESXi host within a cluster. Distorted slot size. So you can see here. This time, even I have 9 gigahertz CPU and RAM also 9 GB. And here 9 gigahertz 7 and 6 gigahertz 7. But you can see the slot size based upon this value, 2 gigahertz, 4 gigahertz. That is what we configured as a reservation. So if we use these parameters and this parameter, 9 divided by 2, even you get 4. CPU slots I have 4, but then 9 divided by 4, you get only 2 memory slots. So the end result is it only can provide 2 slots. Because VM needs CPU, VM also need memory. So when you power on 2 virtual machines, so it means all the memory slots finished, consumed. Even I have 2 more CPU slots, but because of memory slots 0, it will not allow to you to power on any single more VM. So you can see these 2 CPU slots going waste. And same thing you can see here, only 1 slot because of memory. 7 divided by 4, 1 point something, so only 1 slots. Even CPU we have 9 gigahertz, but still you can use out of 4 only 1 slots. 3 slot wastage, 3 slot wastage, 3 slots wastage, and 2 slot wastage. If you do not make homogeneous cluster. And this type of cluster, we should, if you have this kind of cluster, you should not consider the first HA admission control policy. You can go for the second or third, or use the manual input, override the default calculus. This is a default calculation. And they say we can use also keep resources spare in percentage, this second policy. Okay, so if you want to see in percentage how much CPU, how much memory we consumed from the clusters, and how much in percentage left free, so you have to use some calculation. The formula you can see. First of all, this is what we have total amount in the cluster, CPU and RAM. And total being used CPU by all 5 VMs currently. Total memory being used by all 5 VMs. That is this one. If we want to see in a percentage how much resources we consumed right now in percentage, and how much resources we left with the free resources in percentage. So this is the formula we can use. Total capacity, total currently being used, that is detected, and divide by total. So that much resources still you have free. That much memory still you have free. So based upon this, you can take a decision how much resources I want to keep free, that you can configure manually. 20%, 30%. You want to keep spare capacity in the cluster all the time, must be available. So whenever any single host failed, other host can have sufficient capacity to recover your all the virtual machine. VMCP, VM component protection. Version of vSphere before 6 cannot detect this condition. Yesterday we discussed all path down condition and PDL condition, permanent device lost. So I remember in a my beginning when I started with the this VMware 3.x version in 2009. Then we used to prepare physical machine, because virtualization quite new that time. So we used physical server to install ESXi, 2 physical machine where we installed ESXi, and 3rd physical machine where we prepared vCenter server and NFS storage. And we have, let's say, 2 virtual machines here, 2 virtual machines here. So that time we also show the high availability. So just to show high availability, what we used, just disconnect the physical cable from the storage from one of the ESXi host. So what it's showing? It's showing now it consider that host no more available. So it's going to recover the virtual machine all here. So it successfully show to you these VM here. The people happy? Yes, I see all 4 VM now running in this ESXi host. But then once they tested it, we saw them this failover event happened, and then we immediately connect this cable. And what is the result? What you can expect here? Now what should happen? Once you connect this ESXi host, hardly after 2 minutes, 3 minutes, what should happen? Can you see this virtual machine or not?
That will still work on the second ESXi, right?
Yeah, so now in the 3.x, we had bugs in this. So what happened actually, when you disconnect this cable, the virtual machine memory state still we have in the RAM, physical RAM of the ESXi host. They are running, user working remotely on the VM. So at the moment you disconnect, the memory state remain as it is of this virtual machine in the ESXi physical RAM, but HA cluster start triggering failover registered virtual machine and power on the virtual machine here. So you have 4 virtual machine here. But later on, when you connect it back, it finds the memory state as it is, and it get now confused. Because the virtual machine memory state I have still in healthy condition and data still now restored, I can able to connect to the virtual machine relevant data. So this get confused. The end result is in just 2 seconds, 4 virtual machine it's showing here. And then in next moment, it showed this blank and all 4 VMs showing here. And after 2-3 seconds, it's showing this blank and all 4 VMs here and keep continue this juggling. This was the bug which gets solved in 4.x. And later on now we have more accuracy to find by once they introduce the APD conditions, pull path down or permanent device leave, because this condition occurs now due to this APD PDL, it triggered the signal, destroy your memory states. So it destroys all memory states. All virtual machine recover in the second host. Later on, when you restore this, it is empty. No virtual machine, no memory state. So this is also, we can configure now APD condition, PDL condition to avoid this kind of, it is also no split brain problem. So it should be destroyed the memory state of the virtual machine. So at a single moment, VM must be running on the single ESXi host. Each ESXi host has its own vSphere HA logs. Per ESXi host, you can see FDM agent and its relevant file. In this location, by using tail directly also, you can read the files. And from where all the services you can start, whether it is hostd, VPXA, or your FDM services. All services you can find under this directory, init.d, where you can also start or stop, restart this H-agent service. The cluster utilizations graph also quickly show to you the CPU consumption, memory consumption at the host level, which are the part of in this cluster. So you can see top level object vCenter. This is a data center. One data center represent one physical geographical location such as Mumbai, Delhi. So multiple physical geographical based data center you still can manage from single vCenter server. So it could be Delhi, another data center could be Mumbai, another data center could be Bangalore. So multiple physical location based data center you can manage from single vCenter server. So under this data center, you can have one or multiple HADRS enabled cluster. And cluster something high availability. So minimum 2 or more ESXi you can put together. Okay, so now they're talking about vMotion. So what is vMotion? What is the use case of vMotion?
Migrate VMs without disrupting service.
Yes, from existing host to new ESXi host. When we need to do this, what is the use case where we can perform vMotion?
I would say DRS makes the most of the use for that, right?
To balance the resources on the ESXi.
Just give me a minute. Maybe guys, we can take a break, short break, 15 minutes, and then come back and we can continue. Is that fine?
Yes.
Sure.
Thank you.